TabFM, a zero-shot foundation model for tabular data. Most machine learning on spreadsheets still looks like this. For every new table, you pick a model, handcraft features, tune a pile of hyperparameters, then train and validate over and over. It works, but it is slow and it is manual. So here is a different question. What if a model could simply read your table, the way a language model reads a paragraph, and give you predictions directly? No training on your data, no tuning, just an answer in a single pass. Language models are trained once and then reused across countless tasks. TabFM brings that same foundation model idea to tabular data. One model pre-trained a single time that works out of the box on many different tables. The trick is in context learning. Instead of updating its weights, TabFM treats your labeled training rows as context, reads your unlabeled test rows right next to them, and infers the answer from the patterns it sees. Learning happens in the forward pass, not in a training loop. In one sentence, TabFM is a scikit-learn compatible model that does zero-shot classification and regression on mixed type tables, missing values and all, without ever training on your dataset. TabFM did not appear from nowhere. It builds on TabPFN, the prior data-fitted network published in Nature, and on TabSCL's efficient in-context learning. TabFM fuses their ideas and trains them at a much larger scale. How do you pre-train a model for every possible table? You invent them. TabFM was trained on hundreds of millions of synthetic datasets, produced by structural causal models with random functions. This sidesteps data scarcity and privacy entirely. So how does it actually work? Under the hood, TabFM is a hybrid transformer with 3 stages. Let us walk through them. At a glance, the table enters at the bottom. First, attention runs across both columns and rows. Next, each row is compressed into a single dense vector. Finally, a dedicated transformer performs in-context learning over those vectors and reads out predictions. Stage 1 alternates 2 kinds of attention. Column attention lets features interact, capturing relationships you would normally engineer by hand. Row attention lets examples compare themselves against one another. Alternating between them builds a rich, structure-aware representation. Stage 2 compresses each row from a grid of cells into a single dense vector. This dramatically shrinks what the next stage has to process, and it is the key to keeping TabFM fast even on larger tables. Stage 3 is the in-context learning transformer. Following TabSCL, it attends over the compressed row vectors rather than the raw grid, which slashes compute. 24 of these blocks let context rows inform every query row before the prediction is read out. Formally, each prediction is a posterior over the label conditioned on your whole dataset, and the engine driving it is scale.product attention, queries, keys, and values, normalized by a softmax. At inference, TabFM concatenates your training rows and your test rows into one big prompt and runs a single forward pass. No fold splitting, no tuning loop. The context is the training. The answer comes straight out. Real tables are messy, and TabFM's preprocessing embraces that. It auto-detects categorical, numeric, and datetime columns, encodes and scales them, imputes missing values, and clips outliers, all before the data ever reaches the network. For extra accuracy, TabFM does not look at your table just once. It builds many diverse views of it, shuffling feature order, shifting class labels, swapping normalization methods, then averages the predictions. It is bagging, but over data representations instead of over models. The full TabFM ensemble goes further. It adds engineered feature crosses and SVD components, runs a 32-way ensemble, and blends the members with non-negative least squares, plus Platts scaling to calibrate class probabilities. Enough theory. The best part is how little code it takes to use, because it looks exactly like scikit-learn. Here is classification in 6 lines. Load the pre-trained model, wrap it in a TabFM classifier, call fit, then predict. Note that fit does no gradient training. It just prepares the encoders and remembers your rows as context. Regression is the same story. Swap the model type to regression. Use TabFM regressor, fit and predict. Same API, different head. TabFM ships two interchangeable backends, JAX and PyTorch, and it downloads its pre-trained weights automatically from the Hugging Face hub the first time you load it. On a GPU, predictions take seconds. So let us put it to the test on two classic datasets: Titanic, a survival classification problem, and bike sharing, a daily demand regression problem. Zero-Shot TabFM against solid baselines on the very same splits. On Titanic, Zero-Shot TabFM reaches 80.3% accuracy and an AUC of 0.852, edging out a gradient boosting model and logistic regression without ever being trained on the Titanic data. On bike sharing, TabFM predicts daily demand with a root mean squared error of about 562 rentals and an R-squared of 0.92, clearly ahead of gradient boosting and ridge regression. Again, zero-shot. Our two datasets are just a taste. On Tabarina, a living benchmark of 38 classification and 13 regression datasets ranging from 700 to 150,000 rows, Google reports that TabFM consistently tops heavily tuned, industry-standard algorithms on ELO. Where does this help most? Instant, strong baselines, rapid prototypes, small to medium tables where standing up a full training pipeline just is not worth it. You get a competitive model in seconds. It is not magic. The released model handles up to 10 classes and caps the features and rows it reads, so very large tables get subsampled. And like any pre-trained model, its behavior reflects the synthetic prior it learned from. Know the edges before you ship it. To sum up, TabFM reads your table and predicts, with no training. It combines row and column attention with efficient in-context learning. It is as simple to use as scikit-learn, and it holds its own against tuned baselines, a genuine foundation model for tabular data.
If you like this video, please subscribe and share. Thank you.